Welcome to part 2 of how to use recursion for nested lists in Python. If you didn't watch the first part, I recommend doing so first. Our next example will be reverting a nested list. So let's write deep reversed. And again, let's use a lambda function. And this time we could try using the reversed function. However, this one doesn't return a list but an iterator, and we need a list, so let's call a list around that. Let's try it. And indeed, it reverses our list. Another question for you. I would like to write a function called deep length, and it should calculate the length of our nested list. So this nested list contains the numbers from 1 to 11, therefore its length is 11. If you want to think about it for a second, pause the video. But I'm gonna start coding it. This example is kind of similar to the sum example we had earlier, because our collect function can just be the built-in sum function again. Our end function, however, should not be the default way of just passing the argument, but this time we don't want to add all of the numbers, but we want to count 1 for each number. That's why this function just returns 1 for every input. If we do that, we should be able to do the same as before. So this function could tell us how long the list would be if we could flatten it. But how do we flatten it? Let's create a new function for this. Let's call it deep flatten. As our collect function, we could use the sum function again, because in Python, lists can be added. However, we need to be careful, because the sum function always starts with the number 0. And this time we want the sum function to start with an empty list, so it doesn't try to add an integer to a list. That's why we use a lambda function again. And for every list x, we return the sum of x and an empty list. Our end function will now be another lambda function, because again we can't add a number or anything other than a list to another list. So we need to wrap a list around each element in our end function. If we do that, we can add those lists with our sum function, and that should allow us to flatten a list. And indeed, we get the flattened list. Our next example will be calculating the maximum depth of a nested list. For example, this list contains this list, which contains this list, which contains this list, and we can't go any deeper than that. So the depth of the list nums is 4. One way to define depth recursively is the depth of a nested list is the maximum of all the depth of the items of the list plus 1. So that already gives us a hint in how we can solve this. We can try to use the built-in max function again, but we need to use a lambda function, because we want to add 1, of course. Maximum of x plus 1. However, it's the same issue that we have before with the minimum, that we don't have a maximum defined for an empty list. Again, we need some if-else logic. If x, else. And in this case, we don't need something like infinity, because we actually define the depth of an empty list to be 1. The end function is pretty simple, because if our element is not a list, then it doesn't have a depth, so we can just return 0. Let's try this. And we get 4. For example, if we did this, we would get 2. Okay, next example. This time we would like to check if a specific value can be found anywhere in our nested list. So what we could do is using the any function as our collect function again, like we did in the deep any example, but our end function would be something like lambda x, and it returns true if our element is equal to some kind of key, and false otherwise. However, we want our function to have both parameters, both the list and the key, so we are going to use the def keyword this time. Let's call it deep in, and what we can do is return this function applied to this list. So if we enter a key and a nested list, this will create this function using the key we entered, apply it to the list and return it. Let's try it. Now let's call deep in of 12 and nums, and it says false because 12 cannot be found anywhere in this nested list. But deep in 11 and nums returns true because 11 is indeed somewhere in this list. In addition to that, we can also create another function. I'm going to call it deep disjoint, and this time it gets 2 arguments, both of which are nested lists, and it's about whether any value can be found in both lists or not. So we could do something similar, but this time we don't care about whether our element is equal to some key, but we care about whether it can be found in the second list. So this time we return deep in of x and the first list. Oh, sorry, I said the second. The second list. It actually doesn't matter, because now we are going to apply this function to the other list. And if I didn't do any mistake, that should work now. However, disjoint actually means that no element can be found in both lists, so we need to write a not before, otherwise the result will be the opposite of what we meant. So this time we could test this function using nums and nums2, which I defined down here. And it says true because, as you can see, the first list contains the numbers from 1 to 11, and the second one doesn't contain any numbers smaller than 12. So they are indeed disjoint. But if I were to say nums.append 12, this time the same function is false. That's all for now. Thank the two of you who are still watching. I have actually never done a video like this before, so I really appreciate any feedback. If you have questions, ask me in the comments. If you expected more puns, insult me in the comments. If you find the example list I've been using disorderly, help sorting out the issue by writing a function deep sorted and sharing it in the comments. Or again, just insult me. Bye!